Hello there, ROS Developers! Do you want to learn what is DDS and run some performance tests with different DDS implementations for ROS2? Then, let's start with the live class. Let's go! Alright, hello everybody, ROS Developers, and welcome to this live class number 87, if I'm not wrong. And today we are going to be talking about DDS, what is DDS and how it affects ROS2. And we are going to be running some performance tests to see how different DDS implementations work in ROS2. So, before starting, let me have a quick look at the chat and see if everything is going properly. Let me say hello to all of you guys. Let me see here. Okay, I can see here we have Ashish, Lagan Kapoor, hello and welcome. Lagan Kapoor is in quarantine from 30 days, he says. Well, yeah. In my case, it's more than 30 days. I think it's already a month and a half or something like that. Okay, I can see here Christoph, Marcus, Carl, Andrew, Bednar, Arif, Gabor, Michael. Okay, so hello everybody and welcome to this live class. So let's go for it. First of all, as always, what I'm going to do is to share with you the project for today, guys. So let me grab it really fast from here, and let me share the link with you so that you guys already have it. So let me look for it here. Here I have it. Okay, so let me put it here in the chat. Alright guys, so there I have placed the project for today in the chat. So next thing is going to be to start. So as always, let me come here to my ROSDS. So I'm going to see you in a moment, but before starting, you know what it's time for. It's time to get here a bit of coffee from my fancy ROS Developer mug. There we go. I'm set up for starting. So let's switch to the computer screen. Alright, so here I am. Then what I'm going to do right now is to paste my own project link to get it here in my space, although I think I already have it. Let me see. Yeah, so I already have it here then. Let me see, because I have here two versions and now 88E and 84. I think this is the good one. Yep, so let me remove this one. All right. Then, as always, guys, we are going to be working on the ROS Development Studio. So if you are already logged in, great. If not, just create an account. It's free and it's done in 10 seconds. So go for it. Then once you are logged in the ROS Development Studio, you are going to be able to get this project, the one I have just shared with you guys. And this project is going to appear in your workspace, in your list of projects. Yeah. So let's see if this finishes removing. There was some kind of problem there in the deletion of the project. I hope everything is fine with the ROS Development Studio, at least. Come on, let's go. Let me check in the chat if everything is going okay for you guys. Because for me it looks like it's going strange, ROS Development Studio. Okay, there we go. Yeah, it took some time to delete, but now it's ready. Okay, so here I have the project. All of you guys should have the same project here. This one for class number 87, understanding DDS in ROS2. Yeah, so once you have the project, all you have to do is to click here on the open button and open project. Yeah, this is going to start loading the environment. There we go. So I'm going to do this right now. All of you do it as well so that the project starts to load. And meanwhile this loads, I'm going to share a couple of things I want to share with you. So first of all, I want to, well, let me get here one link I'm interested in. There we go. Okay, so first of all, here in the ROS Development Studio, I don't know if you are aware of it, if you are already in or not, but we have recently, a couple of weeks ago, created the ROS Study Group, which basically, if you click here at the bottom right corner of the ROS Development Studio screen, it's going to take you to the Discord server of the construct, so to our Discord server, where you can see we already have 370 members, almost 400. Then you can enter our Discord server and you are going to be able here to talk and discuss and chat with many people which has the same interest as you in terms of robotics. So many people who is trying to learn ROS or it's developing projects in ROS. So guys, I really encourage you to join our Discord server to make bigger there is ROS community, so that all of you get to know each other and share your knowledge and help each other. Yep. Also, very soon we are going to be releasing some news here for the Discord community, some ROS challenges and some interesting things. So stay tuned and join our Discord server to be aware of the latest news. Yep. All right. So this being said, the next thing I want to talk to you, it's about the ROS Developers Day that it's going to be pretty soon already. So let me share with you as well, guys, the link here in the chat. All right, so as you can see here in June 27th, we are going to, more or less in a couple of months, we are going to have the ROS Developers Day, which is going to be basically a full day with many conferences related to robotics, related to programming robots with ROS. It's going to be virtual, as always, using the ROS Developer Studio, so that meanwhile you are listening to the conference, you can practice everything you are doing. So yeah, guys, have a look and register. It's going to be great. Each year, this is already the third year that we are doing this ROS Developers conference. The previous years we did it in 2 separate days. For this year we have decided to make it everything into one single day. So yeah, guys, we are going to have many interesting conferences from many ROS specialists. So yeah, guys, have a look, and if you are interested in, just register. All right, then let me see if this has loaded. Yeah, so my project has already loaded. Then let me close this and let me prepare everything. So I'm going to make this notebook here bigger. So at this point, you should have your project loaded, or maybe it's still loading, I don't know. If it's still loading, don't worry. It's going to load in 1 minute or something like that. So just be patient. Then once it loads, you're going to see the project here for the live class number 87. Yeah. which is the ROSject that we are going to be working with today. Yes, so today we are not going to be using any simulation, so today it's going to be a more theoretical live class, let's say like this. We are going to do some practice and do some tests, some performance tests, but we are not going to be working with any simulation. So for today, I don't need you to start any gazebo simulation, just load the ROSject as it is. Yeah, like I have it right here. Yep. Then let me have a look here at the chat if everything is going fine. Yes, no. Sirajudin says, can someone share Discord invite link here? Okay, so Sirajudin, you can directly join the Discord server, as I've said, by clicking here in the ROS Study Group button at the bottom right corner. Here, if you click here on the ROS Study Group, this is going to directly take you to our Discord server so you can join it. Yep. So let me have a look here. Loaded, okay. Can someone share Discord invite link here? Okay. All right. So I suppose everybody has his ROSject loaded. Yes. All right. So, as you can see here, the live class of today is going to be focused on understanding DDS in ROS2 and doing some performance tests to check the performance of different DDS vendors. Yeah. So, in order to follow this live class, in theory, you are not going to need any prerequisites. However, it's always good to have the Linux basics to understand and follow the commands I'm using. Yeah, we are not going to be doing any Python code, however, but it's also interesting to have some knowledge related to ROS2. Yes, because this DDS, it's used basically in ROS2. It's new. Yeah, so in ROS1, it was not used. We are going to see it right now. So yeah, you can check here our online free courses for Linux and Python, just in case you are interested, or for future live classes in our Robotic Night Academy right here. And also the ROS2 course, which I'm going to go back to this later, so don't worry. Then, before starting, let me actually have a look at the chat and see if everything is going fine. Any new comments? Yes, no? No, I can see no new comments here. Let me know, guys, real quick here in the chat if everything is fine. Your ROSjects are loaded and everything, so that I can continue with the class. Everything okay, everything good. Yes, loaded, all fine. Okay, great. So let's go for it. Then, what is DDS? Basically, DDS, it means Data Distribution Service. And this DDS is a middleware which goal is to enable high performance data exchanges, so communications, using a publish-subscribe method. Yes, this publish-subscribe method, it's very similar to the one used in ROS with publishers and subscribers. Yes? So basically, it's a middleware which enables high performance communications. Yes? Then, you might be asking, okay, but DDS is the same as ROS. Yes. Then, because you are saying that it uses this publish subscribe method, which is very similar to ROS, so it is the same as ROS, DDS. No. So DDS is just a communication standard. Yeah? So it's an industrial standard, let's say, for communications, for high performance communications. Yes? So its market, it's huge. It's used in many different fields like military field, air traffic control, autonomous vehicles, medical devices, etc. Yeah? Then DDS is a communication standard. ROS2, it's more like an ecosystem. So it provides a friendly framework for basically roboticists, yes, because ROS is aimed to robotics. So ROS2 is on a higher level than DDS, yeah? So it provides higher abstraction than DDS. For instance, in ROS2, we have the already ready-made data types, which are the ROS messages, ready-made packages, libraries, etc., which are aimed to help robotics developers. Yes? So basically, ROS2 is built on top of DDS. Yeah? So, summarizing, DDS is a middleware that provides some features which are important or relevant to ROS, such as distributed discovery, which is a difference from ROS1, we are going to see right now. Or, for instance, also you can control or customize the quality of service options for the transportation. Yeah, this subject we are not going to treat it, the quality of service setup. We are not going to show it today, but probably it's a very interesting topic that should be covered in some future live class. Yeah. So how does this quality of service work in ROS2? Then DDS is not used in ROS1 because here we are talking about ROS2. So DDS is not used in ROS1. No, DDS is not used in ROS1. Yeah. So in ROS1, the communications standard was a custom protocol. Yes. For instance, TCP ROS or UDP ROS. So basically in ROS1, some protocols were grabbed like TCP or UDP and they were customized for ROS. Yes, creating this TCP ROS or UDP ROS. Yes, then there are some differences here we can see in this image here, differences between ROS1 and ROS2. Yep. So basically here we are differentiating between three different layers, which are the OS layer, the operating system, the middleware, and the application layer. Yeah. So the application basically is what a normal user of ROS is going to work with. Yeah. So in ROS1, if you know ROS1 and you know the architecture of ROS1, we had the master, yes, the master node, and from this master, everything else was pending. Yeah. So we had the different nodes, application with the nodes, the topics, the communications between topics, etc. Yes. However, then we had the client library, which was the library that communicated between ROS and the communication and the communication protocols. Yeah, TCP ROS or UDP ROS, as you can see here. Yes, and finally we have the OS layer, which in this case is Linux, because ROS1 works for Linux. Then in ROS2, as you can see, we eliminate this master. Yeah, so in ROS2, there's no, all the nodes are not depending on one master. Yeah, this is not how ROS2 works. In ROS2, we have all the nodes and we have no master. Yes. Then in ROS2, we have the client library as well, and we have the protocols here, the DDS, which would be, let's say, would be the equivalent to TCP ROS. Yeah. And then between the client library and the DDS, we have an abstract middleware here, which performs the communications between the ROS application and the specific DDS vendor, DDS implementation. Yes? So, basically, in order to use DDS, in ROS2, we need to create this layer here, which is not in ROS1, as you can see, because it was already customized here. So in ROS2, in the architecture of ROS2, we have the DDS, we have the client library, but in order to communicate DDS with the client library, we need to generate this abstract, this middleware, which is known as the ROS middleware interface. Yeah, RMW, basically. Yes, so this allows us to be able to use different DDS implementations, because DDS, it's just a standard. Yeah, it's a communications standard. But there are then different implementations. Yeah, so each vendor has its own DDS implementation. Yes? Then in ROS2, we can switch the DDS implementation to use, depending on our needs, by switching as well this middleware layer, this abstract DDS layer. Yes? So this also could be removed if in ROS2 we were only using one DDS implementation. Yes? For instance, the fast RTPS. If we were only using the fast RTPS, then we wouldn't need to have this middleware. Yes, because we would always use the same DDS implementation. However, it's much more interesting to allow to switch the DDS implementation. Yes? Depending on the needs of each project. Yes? Then this, keep in mind that this DDS implementation can be switched. Yes? So you can switch the DDS implementation to use in ROS2 depending on your needs. However, then if you switch this DDS implementation, you are going to need to switch as well the ROS middleware interface, this one here. Yes? Then finally we have the OS layer with the different operating systems that can work with ROS2. Yeah, it's more or less, I know this is a little bit abstract and complicated, and maybe complicated, but have you more or less understood the difference between ROS1 and ROS2 in terms of communication standards and communication protocols? Andrew asks, DDS became a critical lower level layer, and I understand its vendors who are accountable for implementing DDS. Yeah, that's right. So DDS is a very, very low layer, and then each vendor is responsible for creating, implementing, and maintaining the different DDS implementations. Then Andrew asks, can we as developers write our own adapter for hardware? Yes, you can, Andrew. For sure you can do that. So that's allowed. Thachary says, I believe there are currently 3-4 implementations, some closed source, but I believe if you implement the core ROS2 APIs and link during compile or run, you could write your own. Yeah, that's right. That's right. So I haven't tried that, of course. So I cannot give you much more information, but it should be possible to do. Yes, for sure. For a drone project, would you use ROS1 or ROS2? I don't know. That's a very difficult question. It depends on many things. See, Judin, it depends on many things. Then Duke Drone Flyer says, so my question is ROS1 outdated? Where today we should use only ROS2? No, I wouldn't say it's outdated. In fact, they are still publishing some new distributions of ROS1. It's just different. So nobody knows if ROS1 is going to, only the time will tell if ROS2 is going to be the only standard and ROS1 is going to disappear, or what is going to happen. However, ROS2, it's a much more robust. So right now there are still it's still under heavy development, ROS2. So there are many things in ROS2 that still need to be developed. Yeah. So at this very moment, ROS1, in my opinion, is more complete than ROS2. Yes, because ROS1 has been there for many years, so you already have many packages that work, many things in ROS1 already done, which are not yet for ROS2. Yes? So right now, I would say that ROS1 is more complete than ROS2. However, ROS2 has many interesting features that in the future, I am sure, that are going to be very important for robotics developers. Yes? Let me see here. So my question is, okay, is ROS1 outdated? So yeah, so right now it's not outdated, Duke. answering your question. Are ROS2 and DDS ready for industrial developments? DDS it is. So DDS is already there and it's already being used in many things. DDS as a standard, it's already being used in many in industrial developments. Yeah, for sure. But ROS2 I'm not sure. I would say that not yet. ROS2 is still not prepared. ROS2 still needs some more work on it. Yeah, however, it's going to be, because ROS2, in terms of real-time control, for instance, it's much better than ROS1. Yes? So, for instance, in the real-time control, the real-time factor, which is very important for industrial developments, in ROS2 is going to be much more, it's going to be better than in ROS1. What is the key usability difference between the two? Are there specific cases where ROS2 is indicated? Well, right now I wouldn't say that. However, for instance, if in the future you want to develop something which is depending on real-time factor, I would go, for instance, for ROS2, as I've just said, because ROS2 it's much more prepared for real time, for working in real time. Yeah, for instance, that would be a case. Another case is if you want to have control over the communications. So if you are interested in going very low level and have control over the quality of services for communication, for instance, then for that you have to work with ROS2 for sure. Yeah, so that would be some cases. Does ROS2 include the TCP-ROS, UDP-ROS? No, Duke, no. TCP-ROS and UDP-ROS are for ROS1. Are custom protocols for ROS1, which work for ROS1. Yeah? Let me see here. Is DDS open source? Where DDS is a standard. Then there are different vendors which have DDS implementations. Then there are some DDS implementations which are open source and some other which are not. Yeah? So it depends on each vendor. But DDS standard. Then each vendor then creates its own implementation using this standard. Yeah? Then it depends on each vendor if it is open source or not. Yep. Okay, so let's keep moving a little bit. So basically, if you have more questions, keep them there, and I'm going to try to answer them later, but I want to keep working a little bit to don't have this too much stopped for too many times. So let's keep going. Then more or less we have explained this and the differences between ROS1 and ROS2 and what DDS is. Yes, and how it affects ROS2. All right, then as I've said, DDS, here we will have the DDS implementation, here we would have the ROS2 client library, and here we would have a middleware which basically adapts the DDS implementation to ROS2. Yes, then we can check, for instance, the DDS, this middleware layer, we can check which one is being used right now. So for instance, for this, we can come here, let's open a new shell, and we are going to check the current middleware. Yeah, so remember the ROS middleware interface. Yeah, so in order to use a specific DDS implementation with ROS2, yes, this would be the DDS implementation. So in order to use a specific DDS implementation with ROS2, we need to create this ROS middleware interface. Yes? Then, which connects the ROS2 in this case with the specific DDS API. Yep. Then, for instance, if we run, let's first of all, we are going to need to source ROS2. So we are going to execute this command we have here in the notebook. Source opt ROS eloquent. So here we are sourcing ROS2 Eloquent. We are working with ROS2 Eloquent distribution. So let's source here the ROS2 version. And then this allows us to use this doctor, this ROS2 doctor command. Yeah, so we are going to execute it right now. Basically, this command is going to generate a report with details about our current environment setup. Yep. You are going to see that this is going to generate a large report with some data. Here you can see. So we have here some data about the network configuration, platform information. We can see here information about the OS used. Then here we have also ROS2 information, which version we are using, ROS2, Eloquent, topic list, etc. And then here we can also see the RMW middleware. Yeah. So currently, as a middleware, we are using this one, the RMW Fast RTPS CPP. Yes. So Fast RTPS, it's basically a vendor. It's a vendor. Well, it's not a vendor. It's an implementation. Yes. Well, this in fact it's a middleware. So it would be this abstract DDS layer here, which allows ROS2 to work with a specific DDS implementation, which in this case it's the Fast RTPS. Yes, the Fast RTPS is a DDS implementation which is created by the guys at Eprosima. Yes, Eprosima would be the vendor. Yeah, and then this Fast RTPS by Eprosima is the standard one, the default one that comes with ROS2. It has full support, this one. And in general terms, I would say that it's the better one to use. Yes. However, now we are going to do some tests. Yes. So we are going to compare this Fast RTPS from Eprosima, which is the default one, as I have just said, with another implementation, which is the Cyclone DDS implementation. Yes, which is a different DDS implementation. Then we are going to run some tests here in order to compare the performance of these two. First of all, we are going to test the latency. Yes, so for testing the latency, we are going to do the following. So let's open here. Let me start from 0. I'm going to open here a new shell. And I'm going to, first of all, execute this command here, which is going to install some things I need in order to be able to run the tests. Yes, this is going to set up a little bit my environment. As you can see here, it's going to install some basic packages, Python packages, etc. By the way, let me open an IDE as well here so that I can have a look on these files. Let me come here and open this. So basically here, as you can see, we are running this setup.bash from the benchmark workspace here. Let me refresh this. There we go. Yeah, so here from the benchmark inside the run folder, here we have the setup.bash, and here you can have a look specifically at everything we are doing with this setup. So basically we're installing some packages that we need in order to run the tests. Yep. No mystery here. Then this has finished. So now that we have installed everything, we can come here to the run folder, and we are going to basically run this latency comparison launcher sh script. Yeah. We can do this with this command here. Yeah, the bash, we are going to run the latency comparison launcher.sh file. We have to specify here the workspace, which is the benchmark Qualcomm workspace, and the results. Where do I want to publish the results? In this case, it's in the results folder. Yeah, and I'm going to run this command right here, which is going to start doing all the tests. We can have a look here at the specifically what this is doing. Yeah. This latency comparison launcher. So as you can see here, it's starting some nodes, it's doing some message publications, etc., in order to test the performance and the latency. Yep, you can see here everything which is being done in this script. We are not going to enter into details because it would be too much, yeah. But basically here you can see everything, all the commands that it's executing. So this is going to generate, now in the benchmark results here, this is going to generate a plot which is going to look like the one we have right here. Yes? So let's see if this finishes doing the tests. Yeah, so it's still here doing some latency measurements, as you can see. Now it's creating the plots, it has already finished it. All right, so this, now it has generated here in the results folder. If we come here to the results folder and we open in this case the localhost, this has generated a folder with the timestamp of today, with some specifications here. The comparisons are run between fast TPS and Cyclone DDS, as I've already commented before. And here we have a plots folder, which has generated a PNG file that we can download. So I'm going to download it right now. Let me download it here. And if we open it, we can here see the latency comparisons between these two DDS implementations, yeah, between Cyclone DDS and fast TPS. Yep, here we can see the latency and here we can see the payload in bytes. So how, depending on the payload, the latency is performing for these two different DDS implementations. Yes, Cyclone DDS is one vendor and fast TPS is another vendor. Yeah. Then we can run the same, for instance, which is done here right now for intra-process delivery comparison. Yeah, so here we are going to do the tests between faster TPS and Cyclone DDS for intra-process communication. Yes, so the communication inside a same process. We can do this by running the same command, but adding at the end an I as argument. Yeah, this is going to define to run the tests for intra-process communication. So let me run them right now here. Let me have a quick look here at the comments. Note the OS layer super turbulent, much wider scope of devices that can be supported. Yeah, so Andrew here is saying that here in the comparison we have seen between ROS1 and ROS2, yeah, in ROS1 the only OS supported by default is Linux, while in ROS2 you can use any OS. Yes. I can see also, can you please repeat the difference between DDS and RTPS? Okay, Yehor is asking here. So the difference between DDS and RTPS, so DDS it's one thing, and so they are different things. So DDS, it's the data distribution service, which is an industrial standard. Yeah, so it's a set of rules that define a communication process. Yes, so DDS it's an industrial standard. It's nothing concrete. Yes. Then RTPS it's an implementation of this DDS standard by yeah. Do you understand the difference? So let me try to think of a different example in order to better explain this. So let's say that DDS it's the DDS it's a way of cooking. I don't know. This is the first thing that it has come to my mind. So DDS it's a set of rules which define something. Yeah. Then DDS would be a certain way, a certain way of doing something, of doing a hamburger, yes? Then RTPS would be someone's way of doing this hamburger in this way. Well, I don't think this is making it any easier. I don't know. Let me think of a way of explaining this better. Okay, how would the lack of... Can ROS communicate between machines if they are running different DDS on each machine? Yes, Guillermo, that's possible. Yes, because ROS, at the end, ROS is going to communicate, as always, through topics. Yeah, through topics and messages. So this is independent from the DDS you are using behind. Yeah? At the end, what matters here... So this is one of the most powerful things in ROS. Yeah? That in order to communicate, it just uses topics and messages. So all this, it doesn't matter in terms of ROS communication. Yeah, it matters in terms of performance of the communications between all these nodes, etc. Yeah, but it's going to be possible. Yes. Thanks. Could I run ROS2? Skiddle, could I run ROS2 free RTPS on an ESP32UC? ESP32 comes with free RTOS. If yes, I don't know. I would have to search about this specific case, but I don't know. I don't know, Skiddle. I can answer you to that. All right, so let's keep going. I don't know what has happened here. There we go. Okay, so here we have run another set of tests, as you can see, for latency. In this case, instead of the local host, we have run the intra-process latency tests, which we can see here in the intra-process subfolder. And if we download as well, we are going to be able to see the plots here and the differences in latency between Cyclone DDS and fast RTPS. Yep. So all of them, let's say all of these implementations are using the DDS standard. However, each of these, it has some particularities. The setup is different, yes? But the standard, the background, it's the same for all of them. Yeah? Then, let's keep going because we have only 10 minutes left and I want to finish this. Okay, so we have run here some latency tests and now we are going to run some, well, we have some advanced usage here. So you can specify here for each implementation, you can specify the specific version, the commit you want. Yes, but however, this is too much. I'm not going to go into this. You can do it by yourself if you are interested in this. Then, now we are going to use some tests that were created by the eRobot guys. Some performance tests for DDS comparison. Yes, so we are going to run the iRobot tests, performance tests, created by the guys of iRobot. Then for this, it's pretty similar to this. So I'm going to close this shell and start from 0 here. So for this, first of all, I'm going to have to source here the iRobot test folder and specifically the iRobot setup.bash. As before, here I'm running a setup bash, which you can find here inside the iRobot test folder. Here you have the iRobot setup bash, which is doing as well, and it's installing some required packages for running the performance test, as you can see here. So nothing different or new here. This is prepared, and then now I can come here to the iRobot test folder. I'm going to create a new folder for the tests, for the performance tests I'm going to create right now. So for this I'm going to set here and timestamp. We are at April 21, and here it's 1851. And let's do the tests for a Proxima in this case, the performance test for a Proxima. Let me do here, yeah. Then I'm going to access here 21. There we go. I'm inside this folder, and now I can run the tests for this implementation, for the fast RTPS by a Proxima, by running this command here. Yeah, so I'm going to copy all this command here, paste it here, and in this specific command I need to specify the typology. I'm going to show you right now this. So this is, here I'm going to set Montblanc. I'm going to use the Montblanc topology, and as well I need to specify this up here in the topology. There we go. I'm going to set up the Montblanc. Alright, there we go, and let me run this right now. Okay, and this is starting all the tests. So basically here, what we are doing, let's have a better look here at this command. So as you can see here, we are loading this profile, which is in iRobot tests, faster TPS profiles, and a certain topology. So here, if we come to this path, to this folder, let me come here right now, iRobot tests, let me open yeah, so here we have them, yeah? So here, as you can see, we have two different topologies inside the iRobot test folder. We have the Montblanc topology and the Sierra Nevada topology. Each one is inside an XML file, yeah? So basically, inside these XML files, if you have a look at them, you're going to have basically the definition of these performance tests, the setup, let's say, of these performance tests, yes? So you can see here some specifications. For instance, here there are some definitions as well at the bottom for the quality of services. Let me look for them. Here you have them, yes, as well in this one. Yeah, so basically these are different topologies for the fast RTPS implementation. Yeah, you can check here the specifications in the XML files. In this case, we are running the Montblanc topology, which has already finished. Yeah. Then what now? Okay, so this has finished all the tests, as you can see here, and this already, if we come here to the this folder, we are going to see here the Montblanc Look with already some files. We can open these files and have a look at them already with the events. On this. Okay, with the events, we can see here latency information as well, resources information, so how much CPU in use, etc. Yes. However, we can plot all this data in order to make it much more user-friendly and understandable for anyone. So for this, I'm going to come here to the folder. Let me come here to the Montblanc Look folder where I have all these files, and here I'm going to run the following command. Yeah, so here I am going to have to specify as well the topology. Which is Montblanc, and I think that's all. Yep. So this is going to generate now here. Let me run it real quick. So you can see this has generated this evaluation PNG file right here in my current tests. Yeah. So I can come here to my folder. Here I have it, Montblanc Look, and I can download as well this file. Let me try to download. There we go. So I'm downloading this evaluation PNG, and this is going to show me these results. Yeah, we can see here the CPU usage, physical RAM, late messages, lost messages, and 2 late messages. Yes. In blue, we have the current performance, so the one we are using now with fast RTPS and the Montblanc topology, yes? And here, it's comparing it in red with a supposed performance on a Raspberry Pi 3, yes? So as you can see, here in red, which is the target, yes? This is comparing these tests with the usage on a Raspberry Pi 3. Yeah, this is how these tests are defined right here. Yeah. So you have to keep this in mind when you read these tests for this case, because in the ROS Development Studio, the memory consumption is much more higher than the one expected in a Raspberry Pi 3. Yeah. All right, then here you have some advanced usage as well, so you can specify different commits for the same implementation. However, you can run as well here the tests for DDS. So let me do this real quick here. So I'm going to run the test for the performance test from iRobot for the DDS implementation right now. So let me do this. I'm going to put here the Montblanc topology, and I think it's done. Yep, I think this is working. Okay, so as you can see here, the first thing we are doing in these commands, for instance, is to set the RMW implementation, which is the RMW faster TPS CPP for the faster TPS case, and the Cyclone RMW Cyclone DDS CPP for the Cyclone DDS. So this RMW implementation, it's this one we saw at the beginning. Let me come here and do again the source of ROS eloquent setup.bash and ROS2 doctor report. Let me run this. Yes, so as you can see here, basically what we are setting, it's this RMW implementation. Yes, this one here that you can see right here. Yes, so this sorry, echo. Okay, this has finished here the tests. All right, so here we have finished the test for the Cyclone DDS. However, we have run them. Okay, yes, we have run, in this case, I have run the test in the same folder, so my mistake. We are 18. Yeah, so I have right now run the test, as you can see here, by modifying the RMW implementation used. Yeah, so it's not the faster TPS anymore, but the Cyclone DDS, which it's the middleware shown right here. Yes, since we are changing this implementation, in one case it's faster TPS, and in the other case it's Cyclone DDS, we need to as well modify the middleware. Yes, this middleware here, which is exactly what we are doing here. Yes, by modifying the RMW implementation. Yes, and this is just for creating the plot that I have just shown here to check the comparisons. All right, so yeah, basically we have finished with this, generating the test and everything. So let me have a quick look at the chat. So as I've said, today it has been a little bit theoretical, more theoretical than usual. Yeah, but when talking of DDS, it has to be like this. Yeah, so it's hard to do it in another way, and we thought it was interesting to show you to show you this way of comparing, generating performance tests for different DDS implementations. So yeah, let me have a look at the comments right now. Let me come here real quick to the comments. Okay, many comments I can see here. Okay. I can see here a comment from Herbert. DDS defines basic procedures and nomenclature in a more abstract, higher level. Implementations like RTPS are lower level with specific functions API defined by vendors. Yeah, that's it. So that's exactly it. So the DDS defines a set of rules, etc., in order to be used. Yes. Then each vendor defines this in its own way, which would be this DDS implementation. Yes, and this DDS implementation each one has its own API. Yeah, so since each implementation, like Faster DPS or Cyclone DDS, has its own API. Then, because the API is different, we need to have also a middleware which communicates the different APIs from the DDS with the client ROS library. Yes, this is basically the usage of this ROS middleware interface. Yeah, this RMW. And let me see here more comments. Commander Cisco says DDS is like HTTP. Different browsers implement HTTP differently, but follow the HTTP protocols. Is it similar with DDS? Yeah, more or less. That's the general idea, Commander Cisco. That's more or less the general idea. As far as I understand, Skidle says, as far as I understand, DDS is working in the local network. What is about multiply robots in the same network? Is there something like a robot name, or should I use topic namespaces for that? Yeah, when you are working with several robots, Skidle, you use namespaces. Always. That's the way to work with several robots, using namespaces. Okay, I can see many questions here. Is there a tutorial on developing a piece of hardware against a DDS spec? I suppose yes, Andrew. I suppose yes. So I have to tell you guys that I'm not a super expert on this. So for some questions which are much more specific, I cannot provide you an answer right now, because I'm for sure I'm not an expert on this. So I'm more an expert. My field of work, let's say, it's more this one here, the application layer. Yes. Because why? Because in ROS1, with this, most of the cases it was more than enough. Yes. Because this was more fixed, let's say. All this middleware layer. Yes. All this has come new with ROS2, and ROS2 is still super new. So I'm not a super expert on this yet. I will have to become one. So the more ROS2 starts to be used, the more we are going to, or at least in my case, I am going to need to learn about this and how to touch on this middleware layer. So yeah, in any case, if you have any particular question, please leave it here in the comments of the video, and we are going to answer all of them. Yes. So because I can see here there are many different questions. So if you are really interested in one question here related to DDS or all these communication protocols, etc., leave it in in the comments, in the fixed comments of the video that is going to be published now when this class finishes, and then we are going to answer it there, yes, so that everybody can see that question and that answer there. Yep. Yeah, the whole idea, Arif says, the whole, Arif, I don't know if this is the Arif that I know or not. The whole idea of ROS2 is to abstract the DDS layer, so we don't need to think too much about it. Just focus on our application. Yeah, exactly. So, so basically all this, the idea of ROS2 is to make a higher level framework which goes on top of this DDS, so that we don't need to worry about it, yeah? So that we can focus on the application layer, which is basically to build our robot applications, yeah? So this is basically the main goal of ROS2, to make all this abstract to us, so that we can focus on just building applications, yeah? However, there could be some cases where people is interested in going to a lower level, yes, and then in that cases you need to know that it's possible to modify here the DDS implementations, etc., yes. But as Arif says, the main idea of ROS2 is to build a framework on top of DDS, yes, so that we don't need to worry too much about DDS and we can focus on creating our ROS applications, our robotic applications. Yeah, so that's a very good comment. I like it very much. All right, guys. So I think I'm going to leave it here. As I've said, if you have any particular question, leave it in the comments here in the video once I publish the video, and also. You can join the Discord server and start talking there. Yeah, so in any case you want to ask any question there or publish any specific information related to this or related to any other thing. Yeah, so go for it. I'm going to finish it right here. So yeah, guys, thank you very much. I felt like today it was a lot of theory. Maybe some things I could have explained them better. But as I've said, I'm not an expert on this, so I'm trying to explain it the best I can to you guys. But hopefully I have seen many messages from you guys that help me to explain this better and make it more understandable. So thank you very much. And yeah, so that's all for today. I'm going to see you next week for the next live class. So thank you very much for attending. And as always, as I'm saying in all the latest live classes, so stay home, stay safe, be careful. We are going to keep providing ROS content for you so that you can keep pushing your ROS learning from your homes without having to go outside. And yeah, that's all, guys. So thank you very much and keep pushing your ROS learning. Bye bye.